Hello everyone, welcome back to your fourth lesson of geometry, 1-4 angle pairs. In the last lesson, you learned about different types of angles, the angle addition postulate, angle bisectors, and today we're going to learn a little bit more about specific angle pairs that you can use to your advantage when solving problems. Many pairs of angles have special relationships. Some of these relationships are based on the measurements of the angles that the pair make. Other relationships are because of the positions of the angles. So when we look at our first two definitions here, adjacent angles, we kind of talked about this in the last lesson, right? Because we were talking about angle addition postulate. Adjacent angles are two angles that are basically just right next to each other. The more specific definition in geometry is that they share one of their rays. So they have a non-shared ray and one shared ray. A linear pair, bouncing off of the adjacent angles, are two adjacent angles where their non-shared ray forms opposite rays, or really just a straight line. So if you see two angles whose non-shared ray form a straight line, that is called a linear pair, which makes sense. It's a pair that creates a line. Alright, so a little practice here. Tell whether the angles are only adjacent, form a linear pair, or not adjacent at all. So this first question is asking about angle AEB, which is this angle, AEB, and BED. So I'm going from B to E to D. So that's actually going to be this entire angle right there. So when we look at these, we see that the shared ray is EB, and the non-shared rays are AE and EB, which are opposite rays. So this is a linear pair. Which, by the way, if you use LP, that's fine. I'll understand that that means linear pair. The next two angles they want us to do are AEB and BEC. So AEB is that same angle that we had in the last one. Now the next angle they gave us is B to E to C, which is this angle. So these two angles do share ray EB, but they do not, AE and EC do not form a straight line, so these are just adjacent. Alright, so now the last pair they want us to do is DEC, so from D to E to C is this angle, and AEB, so from A to E to B is this angle. Now, those angles are, they do share E, so that might confuse people to think that they're adjacent because they're using one of the same points, but they do not share a specific ray. Angle AEB has rays EA and EB, where angle DEC has rays EC and ED. They do not share any rays. So these are not even adjacent. So these are not adjacent. They do not share a ray. Alright, so now what I want you guys to do is try out numbers 4 through 6 with the second picture and pause the video, try those out, and when you come back, I'll have the answers. Okay, here are the answers. Let's go over them. So angle 5 and 6, so that's going to be this angle, 5, and this angle, 6. They share ray PU, and their other rays create a straight line, so that is going to be a linear pair. Now the next one's a little tricky, angle 7 and SPU. So we have angle 7, which is this angle, and angle SPU. Now this one might trick people into thinking, well, alright, they both have ray PS, so that means they're adjacent. But two angles cannot be adjacent if one angle is part of the second angle. So angle 7 is actually on the interior of angle SPU, so they are not adjacent because angle 7 is part of angle SPU. Then the next one, number 6, is a little easier. We got angle 7, which is this angle, and we have angle 8, which is this angle. Same situation as the above question. They share point P, but they don't actually share a ray, so those are also not adjacent. All right, now we have two more definitions of different types of angle pairs, and this is where it kind of gets interesting because now we're talking about specific numbers with these angles. So complementary angles are two angles whose measures have a sum of 90 degrees. So in this case, angle A and B, so angle A is 53 degrees, angle B is 37 degrees. If we add those together, we get 90 degrees. Then we have supplementary angles, which means two angles that add up to 180 degrees. So in this case, angle A and C are supplementary because angle A is 53, angle C is 127, and if we add those together, we get 180 degrees. Now, I'm going to tell you guys something my geometry teacher told me to help me know the difference between complementary and supplementary angles. My geometry teacher told me that if you got a 90 on a test, you would receive a compliment. Now, I always found that weird because I feel like if I also received 180 on a test, I would probably get a compliment. But if we're keeping things in reality where the scale is 0 to 100, it kind of makes sense. So if you get a 90 on a test, you get a compliment. Then supplementary would be 180 because it's the only other option. You can basically find, if we want to talk algebraically here, you can find the complement of an angle that measures x degrees by subtracting its measure from 90, or doing 90 minus whatever the angle you already know is. You can find the supplement of an angle that measures x degrees by subtracting its measure from 180, or basically taking 180, subtracting the angle you already have. Now, something we'll go more into detail with in a later lesson is the relationship between linear pairs and supplementary angles, but I just want to kind of get that settled right now, and we'll talk about it in a later lesson. But if I have these angles A, B, D, and DBC, and I see that they're adjacent and they form a straight line, that's a linear pair. Now, you should remember from the last lesson, when we have an angle that's technically a straight line, that is called a straight angle, and that angle equals 180 degrees. So this tells us that every linear pair equals 180 degrees. So every linear pair is supplementary. But that does not mean the other way around. That doesn't mean every supplementary pair of angles have to be a linear pair. And to look for an example of that, you can look right back into this box. This angle 53 and this angle 127, they add up to 180 despite the fact that they're not adjacent to each other. And that's allowed. They're still allowed to be supplementary without being a linear pair, although every linear pair is supplementary. All right, some quick examples of using the idea of complementary and supplementary. So this first question says, find the complement of f. Well, remember, complement goes with 90, so I'm going to say angle f plus something I don't know should equal 90. I know angle f's measure is 59, so I say 59 plus x is equal to 90. Now if I want to solve for x, I'm just going to subtract 59, and I'm going to get x equals 31. Now, so that's 31 degrees. Don't want to forget the degree symbol because this is an angle. So if you were able to just look at this and go, oh, 59, what plus 59 equals 90, 31, and you're done with the problem, that's totally fine. I'm just showing you the algebraic way. That should always work. All right, let's look at the next question. So the next question says, I want the supplement of G. So supplement is 180. So if we're thinking about this like the last problem, I should set up an algebraic formula and say, all right, well, angle G plus x equals 180. And that would be nice, except in this question, they don't give me a number for the angle. They give me an expression for the angle. So for this one, instead of setting up an algebraic formula, because I'm not going to get an actual numerical answer here, I am just going to say, well, I know the supplement of any angle is 180 minus that angle. I am just going to say, all right, well, the supplement here should be 180 minus the expression that represents that angle, which is 7x plus 10. Now, remembering our arithmetic rules, distribution, we should be distributing that negative, and we get 180 minus 7x minus 10. We can combine the 180 and the negative 10 to get 170. So we know, we don't actually know any angle here, but we know that the supplementary angle of angle G would be represented by the expression 170 minus 7x. All right, so here's the point again in the video. Pause the video, try numbers 9 and 10. When you come back, I'll have the answers for you, and I'll explain them. Okay, we're back. Number 9, they wanted the complement of angle E. So first of all, we think complement, we think 90 degrees. We see that this is not a known angle, but an expression. So we say, all right, well, the complement of that has to be 90 minus that expression. Again, I'm going to distribute to the entire expression. I get 90 minus 7x plus 12. Add the 90 and the 12, and I get 102 minus 7x is the expression that would represent the complement of E. Next, we want the supplement of angle F. Supplement is 180. I have an actual angle here, so I'm going to set up my algebraic formula saying, all right, well, angle F plus an unknown angle, that's going to be the supplement, should equal 180. Replace angle F with the known angle, 116 plus 0.5, plus x equals 180. I want to solve for x, so I'm going to subtract 116.5, and I get x equals 63.5. And, if you want to double check, just add 63.5 to 116.5. It should equal 180 because they're supposed to be supplementary. All right, this question is actually why I was showing you the algebraic way to solve these, because even if you could have solved the questions in the last slide without using algebra, if you were just able to look at it and say, all right, well, I'm just going to do 180 minus this, I'm just going to do 90 minus this, a question like this is going to be a lot more difficult to tackle without the use of algebra. So this question says, I have an angle that is 10 more than 3 times the measure of its complement. Find the measure of the complement. All right, well, so since we know they're complementary, we know there's 2 angles. So since we don't know either of the angles, I'm going to call one of the angles x. So one of my angles is called x. And I know that the other angle, let's say x is the complement, then the other angle should be 3 times the measure of the complement and 10 more than that. So I'm going to take my first angle, which is the complement, and I'm going to say, well, I want 3 times that angle, so 3x, but then I also want it to be 10 degrees more, so I'm going to add 10. Now I have an expression that represents my original angle and its complement, and since I know their complements, I know that those 2 angles should add up to 90 degrees. Again, this is a complement. Complementary means 90. So I'm going to add up to 90 degrees. Now I combine like terms. I get 4x plus 10 equals 90. Subtract 10. I get 4x equals 80. Divide by 4. And I find out that x equals 20 degrees, right? Because x is a degree measure. Now, it says find the measure of the complement, and I called x its complement. So I actually just solved the problem, but let's say it said find both angles. Now since I know x equals 20, if I want the other angle, I just need to take that 20 and plug it in for x in the expression I already created. So 3 times 20 is 60, plus 10 is 70. So the other angle would be 70 degrees, and that makes sense because they're complementary. They should add up to 90. 70 plus 20 does equal 90, so my answer is valid. And finally, we have our last pair that we're going to talk about today. Those are called vertical angles. Basically what a vertical angle is it's two angles that are across from each other. So for example, angle 2 and angle 4, but it's not enough for them to be across from each other. They need to be across from each other when formed by two intersecting lines. So for example, if I had this situation where I had this angle, let's just call it 1, and then I had this angle, angle 2, those angles, although they are across from each other, would not be vertical because this ray and this ray do not form one ongoing line. They're completely different lines. So although these are across from each other, they're not vertical because they're not made from two intersecting lines. And the fun thing about vertical angles, and again, like this is something for a later lesson, but I'm going to let you know now so that you know that vertical angles are important. The good thing about vertical angles is that if you can spot vertical angles, they are equal to each other. And this will become very useful when we get to the second and third chapters of geometry and we're trying to prove that lines are parallel or that triangles are congruent. We're going to need to show that specific angles are equal, and if we know about vertical angles being equal, it makes our lives a lot easier when trying to find specific angles that are equal. So, quick example. I know I didn't describe this like very specifically, but it's just something that you gotta look out for and understand. So let's look at this example. It says, name a pair of vertical angles. So the first thing we want to look out for is, do we have two intersecting lines? Yeah, we do. We have two intersecting lines that intersect at M. So what that means is, if I see two angles that are going in opposite directions from that point of intersection, those are going to be vertical angles. So the first pair that I see, and you might have saw the other pair first, but we'll get to that. So the first pair that I see is angles HML, so angles HML, and angle JMK. And those both start at point M and go in opposite directions of each other. So they are vertical angles. Now, there's a second pair of vertical angles. There's another two angles that start at M and go in opposite directions of each other. And that is going to be angles HMJ, which is going upward from M, and angle LMK, which is going downward. So HMJ and LMK are also vertical angles. So it says name the pairs of vertical angles, so I should write those down too. Angle HMJ and angle LMK. And this is actually a perfect example of what we talked about in the last lesson, where you can't just call an angle by the vertex when there's multiple angles coming from the vertex. HML, JMK, HMJ, and LMK all have vertex M. So if I just called one of them angle M, you would not know which of the four I was talking about. But because I used three-letter names for these angles, you now know exactly which angles I am discussing. Okay, so here are the lesson review problems. Pause the video, try them out, and when you come back, I'll have the answers ready for you. All right, here are the answers. Let's discuss. So the first question says we have two measures, angle A and angle B. We know angle A is 64.1. Angle B, we have an expression 4x minus 30. And we want to find the measure of each of the following. The first question says the supplement of A. So again, supplement we know means 180. So we want angle A plus some unknown angle, which we're considering the supplement, so x, to equal 180. So I replace angle A with what I know it is, 64.1. 64.1 plus x should equal 180. So to solve for x, I subtract 64.1. And don't be, Don't be shy to use a calculator here, guys. It's totally fine. We all have calculators. If you need to use one, use one. And we get x equals 115.9 degrees. The next question says we want the complement of angle B. Well, angle B is an expression, so I'm not going to be able to solve for an exact number here. So I'm going to say, all right, well, if it's a complement, 90 minus that expression should tell me the expression that represents its complement. So I distribute that negative, I get 90 minus 4x plus 30, combine like terms, and I get 120 plus 4x equals the expression that represents the complement. Again, I don't get an actual number, but if I figured out what x was, this expression would help me get that number. The next question says, determine if the statement is true or false. If it's false, explain why. So the statement that they give you is, if two angles are complementary, again, remember what complementary means. Complementary means they add up to 90, and they are congruent. So they're congruent angles, meaning they have the exact same measure. Then the measure of each of them is 90 degrees. Well, if they're supposed to add up to 90, and they're supposed to have the same measure, if both of them are 90, they're not going to add up to 90, they're going to add up to 180. So there's actually two ways to answer this question. We could either, there's only one way to say it's false, but there's two ways we can correct it. We can either correct the word complementary, because if they're both 90, that would mean they add up to 180. So that means they're not complementary. They are, in fact, supplementary. But I decided to keep the if part. And I said, well, if two angles were complementary and congruent, they'd have to have the same measure and add up to 90. The only two of the same measure that would add up to 90 would make both of them have to be 45. If they were both 45, they would both be the same measure, 45, and they would add up to 90, which makes them complementary. Okay, here are the last two questions in your 1-4 packet. Try these out, pause the video. When you come back, I'll have the answers for you. Okay, here are our answers. Let's discuss. So the question gives you two angles with expression. So XYZ is represented by 2x. The measure of PQR is represented by 8x minus 20. The first question tells you, all right, pretend or imagine that those two angles are supplementary. Find the measure of each of the angles. Well, supplementary, as we know, means adds up to 180. So in this scenario, I'm going to take my two angles, XYZ and angle PQR. Their expressions should add up to 180. So 2x plus 8x minus 20 should add up to 180. Combine like terms, I get 10x minus 20 equals 180. I now need to solve for x, so I add 20 to both sides. I get 10x equals 200. Divide by 10. That gets me x equals 20, which is great, except if you stop there, if this was a test, you would lose a majority of the points of the question because the question doesn't say solve for x. It says find the measure of each angle. So now that I know x, I should be able to find the measure of each angle because I have expressions for each angle. So xyz is equal to 2x. So 2 times 20 tells me that the measure of angle xyz is 40 degrees. The measure of PQR is 8x minus 20. So again, I take my 20, that's x, plug it in for x in the expression. 8 times 20 is 160. 160 minus 20 gives me that 140. And now when I look at my answers, I'm going to see, does that make sense? Well, one of them's 40, one of them's 140. If I add those together, I get 180. So it works. I found the two angles that would meet all of the requirements of being those expressions and being supplementary. Now I look at the next question. It looks very similar. The only difference is it now says XYZ and PQR are complementary. So I'm going to do the exact same thing. I'm going to say, all right, well, I'm going to take my two expressions, 2x, 8x minus 20, add them up to equal 90, instead of 180 this time, because we're talking complementary, not supplementary. Combine like terms, 10x minus 20 equals 90. Solve for x, add 20 to both sides, divide by 10. I actually get, in this scenario, x equals 11. And it should be a different number, right? Because I'm trying to add up to 90, not 180 this time. So I get x equals 11. That's not my answer. I now need to plug this in to both of my angles to find the actual angles. So if XYZ is represented by 2x, 2 times 11 is 22 degrees. PQR is represented by 8x minus 20. Plug in 11. 8 times 11 is 88. 88 minus 20 is 68. So the measure of PQR is 68. Let's see if this makes sense. Does 68 plus 22 add up to 90? It does. So not only are these correct for the expressions, they are correct in the fact that they are complementary. So that answer must be correct. All right. I hope you understood what we talked about in this lesson. If you didn't, I know there was a couple definitions being thrown at you. Feel free to rewind, listen again, jot down any questions you have for us to discuss during class. Have a great day.